You can never have enough examples, so we're going to do one more example with fractions. I'm going to solve this problem by completing the square, so I'm going to add 4 to both sides of the equation. I'm going to factor out the 3. Half of 3 is 3 halves. 3 halves squared is 9 over 4. Now, when I multiply 3 times 9 over 4, that gives me a positive 27 over 4, which is what I need to add to the right-hand side of the equation. We have 3 times x plus 3 halves, quantity squared, equals, now 4 is the same as 16 fourths, plus 27 fourths is 43 fourths. We're going to multiply both sides of the equation by 1/3. X plus 3 over 2 quantity squared equals 43 over 12. Now I know I'm going to need a perfect square in the denominator because I'm going to square root both sides. So I'm going to kind of look ahead here, and I'm going to multiply the numerator and the denominator by 3 so that I have 129 over 36. And now we're going to square root both sides. And whenever we square root both sides, we've got a plus or minus. I'm going to take it up here. X plus 3 over 2 equals plus or minus the square root of 129 over the square root of 36 is 6. So x equals negative 3 over 2 plus or minus the square root of 129 over 6. Now some answers may require a common denominator. So they may say, well, let's multiply the numerator and the denominator by 3 so that we can get a 6 as the denominator. And then the numerator becomes negative 9 plus or minus the square root of 129, and then that is all over 6. Now personally, when I'm completing the square, I like this form of the answer much better. However, depending on the author of the book that you're using or the worksheets that you're using, it's going to depend on what they like when they create the answer key. And that's another great example of completing the square when solving quadratics.